Hi, Gerard. Hey, Dimitri. Mitch.
Hey, Sane. How's it going, man?
Fine, thank you.
Yeah, finally get to see the face.
Yeah.
He's trying to upscale the demos by having a nice title screen.
Yes. Today's demo is a bit different. So we're just gonna wait for a few sec to see if anyone else wants to join.
Do note that you're recording right now, so you may want to put a pause on it.
I'm gonna stop. So hello everyone and welcome to this week's distribution demo. This week's demo is a bit different. In this week's demo, I want to discuss a proposal for developing GitLab operator. To start with, I just want to go through some of the challenges and difficulties that we have for developing operator at the moment, and then I'm gonna pitch the proposal, and then we will get a chance to discuss, and hopefully we can continue discussing it offline or async. So without further ado, please let me start. So GitLab operator is becoming a mean of distribution along with Omnibus and GitLab chart, and soon Operator Hub will be one of our distribution channels. Comparing to Omnibus and Helm chart, we have a bigger vision for Operator because we are aiming for higher capability levels, which does not limit to installing and upgrading GitLab, but rather operating and driving GitLab in runtime environments. So it means that it will accumulate some of the operational knowledge that we have about GitLab and managing and maintaining GitLab. So if we look at the complexity of GitLab deployment, that complexity reflects itself in GitLab operator as well. So we already have a very complicated chart, and we are heading for a very complicated operator. And with operator, things get even more complicated. So let's take a look. So when we come to the difficulty of deploying GitLab, Omnibus manages it very well because we have Omnibus and Chef DSLs. We have many well-established patterns and behavior, EDMs and utilities, and very well structured to absorb that complexity and break it down into Omnibus. And mostly because, first of all, Omnibus had a very good foundation, and secondly, it has been around for a long, long time. We have worked on it a lot. GitLab chart, not so well, probably because some of the challenges come from the Helm itself, because the template language, the structure that is imposed by Helm. But we are getting to that point that we are identifying patterns and we are using best practices to maintain the chart, but not comparable to Omnibus. GitLab operator is like Wild West right now because operator framework and controller runtime just lay the bare foundation, and after that you just need to go and write a shell script with Go, which is, most of the people in this demo know that it's not fun. So it is difficult to maintain that, and it is getting more and more complicated. So we expect to bring more of the operational knowledge into operator with this complexity, with these difficulties and lack of a clear platform, a good foundation. So the challenge here is that we want to develop something in GitLab, a GitLab operator in GitLab. It is iterative. It is going to be in collaboration with the community. So we want to keep adding features to it, and make sure that it doesn't break while we are adding more features or improving them. And at the same time, we want to get feedback and improve it all the time. At the same time, we want it to be clear enough for our own sanity and our community's understanding, because basically we want to have that reliability by being readable and testable. So these are actually show themselves in the design forces that we I translated those requirements into some of the design forces that in turn turn into a framework that I'm going to present. And if I want to break them down, it's basically extensibility, clarity, and testability. And I will try to show them when we get into it. So my proposal is GitLab operator framework. It starts when exactly where the operator framework SDK and the cube builder stop. They just build the scaffolding of the framework. They give you some of the basic tools that you need to build your framework, your operator, and just leave you there. So exactly there, this framework comes in, and it provides an abstraction of what operator does. So basically, from this perspective of this framework, an operator first provides managed resources, everything that needs to be deployed, some of the basic Kubernetes constructs, and then it gives you a way of running workflows, defining and running workflows. And when we get to the examples, I can show you this in code, and you will get a better understanding of it. And it also gives us a set of building blocks that we can put together and build the operator and express the operator in a very descriptive way, rather than just the flow of the process. And finally, we have a better structure around the operator. So I'm just going to go through some of the basic concepts. These are the constructs that we will see in the demo. For managed resources, we have inventories, which is basically collection of resources that we collect, we gather from different sources. We have queries to sort, to go through these inventories based on different search criteria. We have the editors, which let us to manipulate the output of those queries, change something in the resources with the certainty of immutability of the inventory itself. We are not going to touch the inventory, but the copy of the query. And we have the adapters, which led us to deal with different versions and different types of custom resources. And finally, for running workflows, we basically have a descriptor, which is fairly simple and gives us what are the tasks that we are going to run. It's basically a normal workflow, simple workflow. At the moment, we don't have forks. It's just a pipeline. What are the tasks, the ordering, conditional execution, etc., and a fairly large task library that can be extended. So let's take a look at the code. Let me just see if I can make it bigger. Yeah. Is it readable enough on the screen? Okay. So this is the operator that was generated by operator SDK cube builder / cube builder. So this is basically our reconciled code. So what we do, we first of all, we start an execution context. The execution context carries out everything that we need to run to execute a workflow for that specific request. So the runtime context, the execution context is request dependent. It runs for a specific request. And different requests will have different runtime contexts. So the first thing that I want to show you is the adapter. The adapter is the bridge between the actual CR and the view of the CR that we see inside the workflow. So if you take a look at the left-hand side, you will see that the controller has an internal package, which is broken down into different pieces. So here's the adapter. what we do here is we just write an adapter function. This is the signature of the function. It receives the execution context and returns a value provider. And the value provider is basically an interface that returns values and hash. This is pretty similar to what we already have as the adapter, the custom resource adapter in the current operator. But it just does a binding of an unstructured payload of the custom resource and a hash, which we will use later for caching. So, and so far it wasn't any real trick, but the trick, the actual fun starts from inventory. So the inventory is the collection of resources that we are going to use. And here's the inventory that we are using for this particular operator. So this is an internal variable. So we have some sort of aggregate inventory, which is a combination of other inventories. And we have a static inventory. A static inventory is just a list of objects. They don't change. A dynamic inventory, on the other hand, is a list of objects defined in the code, but can be touched by some editors when they are asked for. So, and they will stay immutable. So here's an editor. This is, for example, set release label editor, which receives the values and receives an object, can typecast the object. Sorry, what was the word in Go? Sorry, yeah, cast the object into a type, change something. For example, I have something here for skip acme challenge, which touches ingresses. I haven't wrote it though. And we have the chart inventory, which basically looks at the path of a chart. So this is how we define the inventory. The rest of how this will be loaded, this will be managed, this will be worked out, is done within the framework. From the operator point of view, this is what you need to define. And if you look at it, it kind of looks like a DSL. Okay, so going back to the controller, we set up the inventory, and now we are going to, and the context is ready. So these are all contextual information. And if you look at it, this doesn't really, the main inventory is actually constant between different contexts. It doesn't change. It is defined when the operator is starting up. So that's one thing to consider. And now going to workflow. Here's the workflow. Again, if you look at the left-hand side, the workflow is moved into a separate file here. And this is basically a workflow. A workflow is a list of tasks. And let me show you the actual workflow here, and we can infer. So this is the workflow. It can include other workflows. So for example, it includes run shared secrets, which we use. By the way, this is a bit old, so the example is a bit old. It doesn't reflect the latest changes that we have inside the GitLab operator. So this is how it looks like. The tasks: create resources. Where are the resources? Select them by kind and component. These are actually going and looking into the inventory. We can set the options of the create resources, then wait for job finish. This is the job that you need to look up, and then timeout. Same thing is for run shared secrets. I defined something here, deploy min.io. These are the smaller workflows that can be included and can be reused. Workflows also, every task also has a guard, which helps us set conditions. So these tasks, this run self-signed certificates, runs only if we check the value, and these values like this. basically those conditionals. We create the resources, again, go ahead and still create resource. We deploy the mean IO, and then at this point, we wait for endpoint to be ready. Waiting for endpoint to be ready, waiting for endpoint to be ready. So, and the wait for has the option of postpone on wait, which basically returns a result that postpones it. And I don't want to really go into the details of what we are doing here. It's basically an example, and it's not an accurate example, but what it basically does, if you take a look at the overall structure, we have a workflow. This is kind of the workflow of GitLab operator before the zero downtime upgrade, near zero downtime upgrade, but this is how it will look like. A set of tasks can be conditional. Each task, we have different kind of tasks which are coming from the task library that we have. So these tasks can be defined. So let's take a look at the definition of these tasks. Of course, this task doesn't run, but this is how it will look like. Ignore if it exists. We can add the options, and we write an execute method for the task. This is how we can add more tasks. So the task library has a set of tasks, and let me show you this, and checks, which is a conditional, actually. Sorry, this is a wait for task. For example, this one, endpoint ready. This is a test. So we have tasks and tests. Tests can be used for guards. So we have tasks and tasks. Let me get into the gut of the operator itself, the framework itself. So here's the workflow definition. So each task is basically an interface that has an execute function. It receives an execution context. And remember that execution context has everything that we need. Client, the request, the inventory, the adapter. So everything that for that particular request is available within the context. So the task receives that and does what it does and returns an outcome, which can be okay, error, or retry. Just these are the three different options that it can have. Some of the tasks are resource bound. So this is the type of thing that we have here, which kind of connects the task to allows us to define tasks that are tied to inventory. For example, for querying inventory and returning a set of resources from inventory. And this is an example of the task, creating resources and waiting for objects. If we do it like this, the framework itself is going to contain most of the building blocks that we need for building operator. Of course, we can add more blocks to it, but it will simplify the way that and tests to it, and it will simplify the way that we can describe, because our actual job would be defining these workflows and going through these workflows most of the time and fixing them or going back to fix them. It also helps us for testing, because a runtime context can be mocked easily. And since it has a lot of interfaces, we can use a Go mock. So what we can do, for testing different workflows and different parts of the inventory, we can basically mock a runtime scenario for a particular scenario, we can mock the runtime context and just feed it to the workflow and get the results and see how the operator or that particular workflow will react to the runtime scenario. So it makes it more testable. We don't need a control plane. We won't need etcd or anything else, because we can run the tests quickly and make sure that the workflows are covering different runtime scenarios. Yeah, this is it. So discussion time. You want me to go back to the code so we can just discuss?
I think this is great. I think especially with the MR that went into the upgrade logic for the operator, it became clear that there's so many conditions to check and scenarios where you want to wait for things versus not wait for things, etc., that it just starts to look like a blob of if else's, and it's kind of hard to track. And then even with that MR, it was so hard to add tests because I would have to mock everything up until that point where an upgrade was happening. And so this idea of abstracting out to these broader concepts and allowing mocking, I think would be hugely helpful. I think my only fear is that we have to also then learn on top of the controller runtime how your abstractions work. But I don't think it's that big of a learning curve. I totally agree. I do think that we can just add then multiple workflows and call the right workflow when the configuration matches what that workflow does, and then it becomes massively easier to add more functionality because it's kind of abstracted away from the details. I really like the idea.
Thanks. About the learning curve, first of all, and the development. First of all, when I was just thinking about it, I thought that it's going to be bigger than this, but weirdly, the number of basic constructs that I needed was much more smaller than that I anticipated. But yes, that's true. There is a bit of, because this is a different framework and it provides a different set of constructs to build. Yeah, there is a bit of, which I think it adds the burden of the documentation and examples, working examples.
So I'm going to very quickly ask you, Hossein, to back up just 1 second, because maybe I missed the first like 15 seconds. I thought you were talking about the operator itself, but you're talking about a testing framework on top of the operator?
Not really a testing framework, but it's more like a framework for writing operator and testing it. Just, basically writing it. It kind of implies that we are going to rewrite the operator with this framework.
I like a lot of what I'm seeing here. It makes a lot of sense and can simplify a lot of things, but I do see a couple pieces here that could be, it's unfortunately, it's part of our own successes to the problems we're producing. First of all, I envision going to something like this, that we're pretty much going to have a release of the operator for every release of GitLab. It'll probably get to the point where it'll be easier to just say this version of the operator is only for this version of GitLab. Today we're trying to do multiple versions by having access to multiple charts and stuff, and I think that's probably going to go away, especially when we go toward this. The other piece that I see, which is probably the bigger issue that just scares me, mostly because it can be a huge maintenance problem. And I'm not sure exactly how to describe this, other than if you look at what the Helm chart's doing with specifically the managing the configuration files and so forth, there's a lot of work, a lot of things in play inside there, that how we construct those config files into the config maps and stuff like that, specifically the formatting of everything. To reproduce that into Go, I don't see a good way to deal with that other than write everything in Go, and then it becomes a huge administrative maintenance burden of maintaining all that in Go. Now, and again, I'm not in the Go world knowing everything that's going on inside Go. Maybe there's some Go component out there that's going to make working with config files and stuff more manageable, so where we could effectively adopt a similar sort of framework for managing a config file, where we have a workflow that runs and says, look for these things and then make these changes to the config file. So
I
maybe
think
there's
I have
something-
I think I have a trick for you.
Okay,
We can use the chart.
we
I can,
could.
I can source the test resources from chart. I mean,
Yeah, so,
rendering
I
the
mean-
chart with certain parameters that will lead to those.
I'm just bringing it up, think about it versus saying, oh, we should go this way. Because I think there's value here. I like a lot of what I'm seeing here. I just want to make sure that we step into it and go, hey, we've got a solid plan to how to move forward versus, oh, we're gonna go do this, and then we start going, oh crap, now we got all this other stuff we have to figure out how to bring forward too. So anyways, but anyways, like I said, I like
I see your point. I see your point.
Yeah.
To be fair, I have a few feedbacks myself. I think the biggest challenge that we have here is that if we decide to go to this direction, then we have an operator that is going to be GA very soon. And then we have a framework that we are advocating for. And then at some point, these two need to meet each other, and when and where that time is. So if we keep developing operator framework, the operator the way that we do, we still have the pain, we still have to go through the pain of developing it like this. And then we know that it is not sustainable.
right.
We know that. I mean,
Yeah.
Mitch,
But what we
Mitch has
what
a
we
bit
do-
of Mitch has a lot of horror stories that he can tell you. But
But
so
what we do have is we have a reference design. The operator we have today is a reference design, so that if we adopt this and go forward with this,
yes.
we now take this and start getting to that same point where they're producing the same output, then we can switch.
So basically, the only thing that we will left after a while is just the know-how of how to write the operator and how the operator works, because we have encoded that and we acquired that understanding, and now we are going to restate it in a different language. Let's say not a
Yep.
programming language, but just basically a communication method.
Yep.
One more thing, I think this is more readable, even for people that, I'm not saying writable for other people, but I think it's more readable for people that don't know anything about Go. Just have a basic understanding of. So we can share it, even with the DevOps.
I would sort of agree with you that it does sort of give some sense of like, I may not know Go, but I can at least understand the basic ideas of what's going on here.
Yeah.
I don't read Go yet, and I can't make heads or tails of it. So I'm just going to ask, I want to ask another question, because I'm trying to gain more understanding. So this is solving, like Mitch, obviously you have more context. So like, I want two things. From Hossein, if you were going to boil this to like 1 or 2 sentences of what does this solve? And then Mitch, as a consumer, what pain points is limiting? Because I'm hearing talk of configuration, but I thought operator was controlling like sequence of events and the configuration was in the Helm chart still. And that operator just deployed the Helm chart. So I kind of want to understand both from Hossein what you're trying to solve, and Mitch what you see so strongly is going to save you pain. Because I don't think I'm connecting those two pieces yet.
Okay, go first. In the broadest term, I'm trying to solve the increasing complexity of operator as we proceed with its development. So far, we have been only deploying chart. Now we are upgrading it, which, by the way, deploying chart was rendering and tweaking it. But now for upgrading it, we need more of the process, the workflow. We are translating a run book into Go, and soon we will have more of automated backup, health monitoring, automatic recovery, other workflows that are other administrative workflows that operator is expected to deliver. So to answer your question, going back to your question, what it does, it basically gives us a way to manage the complexity, absorb it, digest it.
Yeah, so to turn that into something more concrete, for example, in the upgrade MR, there's a lot of if-else's that end up coming into play where we start getting into these chains of events like, well, if pre-migrations have run, but post-migrations have not, but it's still in an upgrade scenario, do this. And if this and this and this, then do that. But if they pass this configuration, then do that. And so it just comes to a point where this concept of a workflow can come in handy, where we can check configuration in the GitLab CR where they've provided their values for what they want from a GitLab, and compare that to the current state of the cluster and pick the workflow that gets them to that state. So now instead of a bunch of if-else blocks in the main controller code, we can kind of define a more generic workflow that accomplishes a certain state and pull in that workflow. Could we do it without these abstractions and interfaces? I think we definitely could. I think part of the reason we feel pain today is that the operator code base that we inherited was just POC, and a lot of our work in terms of adding functionality is also cleaning things up so that it's just more readable and manageable. And so I think we honestly could get to a point where the operator code base is cleaned up and easy to follow, and we wouldn't necessarily need something like this. The added benefit here is that if we can mock these, because their interface isn't so high level, we can mock in our tests all the way up to these certain conditions without having to worry about interacting with the API server. Because today, if I want to mock that the migrations job has finished, I have to go like push a change to the API server saying override this and mark it as successful. I don't really need to test Kubernetes' ability to modify API objects. I just want to validate that when a certain state exists, this workflow results in something that I want, the end state. And so it kind of abstracts us away from retesting things that are probably already tested upstream, and gives us the ability to just say, in this workflow, if I have this current state, does this workflow get me to the desired state without having to worry about testing against the API server and stuff? Again, I think we could do that without these abstractions. It just makes it a little more readable for people and helps us a lot with testing.
No, but I think I understand what you're putting down. So I'm going to step up one more level of abstraction higher than this. And this goes back to a conversation I've been having with DJ and Jason and Stephen over the past probably year and a half. You know, we're talking about states and knowing, like, when you're upgrading something, one of the things that I desperately would like to see us develop is this concept, again, back to that, like we have our build vision thing, right, that I've been articulating about our builds, but GitLab is GitLab. And we have this split right now where we see, like, this is the operator and it's different than our charts and it's different than Omnibus. The thing is, inside, when migrations run, all that language that you just used, Mitch, about knowing when and why and what for a state is the exact same things we talk about, whether it's operator, Helm charts, or let me turn my camera on. Sorry. Whether it's, you know, Helm charts, operator, or Omnibus. So I feel like one of the things that we're going to want to do here is step back and say, well, wait a minute. Why are we configuring each of these in separate? It's the same configurations. Like to Gerard's point, right? If we're pulling it out of the config maps and generating it in Go, what does that mean? I would go further. If we're talking about this, can we just manage configuration? Because a GitLab YAML is going to be a GitLab YAML, whether it's anywhere. So can we step back? And if we're going to try and architect this, can we make something that will unify our configurations so that each of our individual things consume this configuration engine that's aware, as a stateful engine, aware of what it takes to upgrade? And then into that, we just have like a factory, using the factory pattern, right? Oh, well, I'm going to use this same logic, but I'm going to plug in all of my machines are Omnibus machines or Kubernetes machines or OpenShift machines or something else. Can we extract that back so that we get something even more impactful that will eliminate a lot of these problems across all of our stuff, right? Because we have a large scalability problem. Going back to Hosein's first thing about Omnibus, I would argue that Omnibus solves well at one, but it does not do as good of a job when you scale it out. But most customers aren't going to want Kubernetes for scaling out because it's just Kubernetes is an answer if you're really big, right? So we have to have some answer for that and for that stateful engine and have it in one place, because we don't want to have Omnibus in one place and charts in the other. We'll always have double work, double learning, double configuration. And we already see that in our, you know, how we deploy. So that's all I wanted to kind of back up to. Love it or hate it, I'm open to.
Robert, I think we are talking about two different dimensions here. What I was trying to achieve here wasn't really just going inside the runtime behavior of GitLab instance itself, but rather how we develop and test, build and test a deployment mechanism of GitLab. So I am really not concerned about the configuration of the GitLab. As a matter of fact, we are just in operator, and here even in this framework, I am trying to piggyback on chart to handle that. So this is like this is completely contingent on what other decision that is made on chart and how it will end up a chart. Basically, if you give me a chart or more charts or many charts, I'm just going to use it. I don't care. And that's it.
Okay.
And how you want to, if you want to upgrade that chart, okay, that's my problem. I need to know what the version you are on, which version you want to go to. I'm going to validate that. I'm going to run certain steps, stop things, start things. These are the things that DevOps, SREs in GitLab.com do to roll out a new version and roll back if needs be. So basically, I think no, this framework really doesn't go that deep. It's just about developing an operator.
Right, but okay, so but I heard you say both. That this is about having the logic to do these things that SREs do.
Yes.
But it's only about having a framework. So where is that logic going to live? You're saying it's about that logic, but it's not about that logic. That's where I'm confused.
No. It is not about how GitLab itself works. It is about how GitLab is deployed. I think these are different dimensions.
I think there's two views here, Robert, and I think all of us are sort of dancing around both of them in a sense. What Hussein has here is really the pieces to manage mostly the Kubernetes or OpenShift world. Some of what you're talking about, Robert, is the next level down is managing that installation image. The operator doesn't really manage the installation image. It just takes that image and gets it deployed and running elsewhere. I like the idea of we have one final configuration of whether it's omnibus or charts or this now the operator or whatever the future things are going to be. We configure it once and get it out there. I like the idea. I don't know how practical it is sometimes. I think a lot of it can be practical, but I'm not sure if it's practical in every single case yet. I'm still running through that in my head, trying to figure out like what are those quarter cases that we need to solve to make it work everywhere.
See, I'm still hearing that duality there, where we say like it's not about the installation of the upgrade deployment process. But here's the thing. If we're managing like what's this current state and I want to go from this version to that version, that is a deployment state engine to know what state does GitLab, the application, have to be in to move it from this version to that version. And that's a common problem among all the ways in which GitLab is out there.
I agree with you to a point. I agree that yes, overall at some point all has to find, yeah, we're probably getting off topic. We probably need to maybe do a separate meeting for this.
But just adding one thing, Robert, the way that operator understands the state of the GitLab, it basically looks in the status of it has two mechanisms in general and nothing more than that. Basically, it looks at the status of the GitLab CR, which it sets, it defines and manipulates itself. And secondly, it looks at the metrics that we haven't added yet, but it will later be added. It look at the metrics that the exporters, GitLab exporter and other Spoke exporters basically export about the status of the GitLab. This is how it. This is the extent of the status that it understands at the moment. Sorry, DJ.
I was just going to say that the example we have here is GitLab specific, but the framework you're proposing is actually like, we're not talking, like in our case, we're talking GitLab, but this framework, your operator framework of yours that you're proposing could actually be used for a workflow in any Helm chart deployment. And that's where it's detached. Like that's where I see it as detached from the GitLab config and the GitLab running instance, is that this proposal is about, this syntax of putting resources into a workflow or guards and deployments and tests into this workflow. And that's not GitLab specific. It's just that we need a tool to improve how we were going to do it.
That's very true. That's basically, you can use it for writing any other operator.
Yeah, I think this specifically, it just helps making the get an operator easier. Whether or not an operator needs to exist, and the merits of that is probably a totally separate discussion. But I would even go further and say this doesn't even have to be an operator based on a Helm chart. We can probably swap out where you get these resources, whether it's from a Helm chart or an API spec in Go that it pulls these, because that might be a future state as well. So I would just say in general, the concept of writing an operator in any language is only several years old, which compared to like Chef and Omnibus, right? That's pretty new. And so there's not a lot of concepts out there yet that make writing the logic of an operator easier. The operator SDK helps us set up the scaffolding to interact with the API server much easier, but all the logic of how to implement, like your business logic, is up to you. And so this just kind of helps solidify that and make that easier. Like I said earlier, we can probably do it without this, but for the concept of this call, this framework that Hussein is proposing could probably live in its own repository, and we import it as a package. And it's not GitLab specific, it's not chart specific, it's just a framework to make the concept of an operator reconcile loop easier to work with, I guess.
Yeah, thanks, Mitch. That's basically the gist of it. That's very true. I just want to point out that there is also a white paper that I wrote a few months ago. It is still in draft, so I'm going to share it. It's in the meeting notes, so we can just go ahead and basically go through the whole rationale and the description, and there are some codex sketches there. Again, these are not real functional codes, these are just basically sketches and some ideas, and would love to hear your feedback. And then we need to decide some practical, we need to make a couple of pragmatic decisions how we want to proceed with it, which is basically this is the to-do part.
Can I just ask the clarification? Or Mitch, when you say that this operator thing is like only last couple of years, you're talking about specifically within Kubernetes, right?
Yeah.
Okay. Because the general idea of what an operator is like from the 1960s. So that's why I'm just clarifying that, like,
No,
it's
I mean,
new to the
yeah,
Kubernetes world, but it's not new.
I just mean, if you look at operators, like they're all a little different. They import different packages. They implement the reconcile loop a little different. Like Kubernetes came out and it had built-in controllers, and then it was after that, some period after that, where it's like, hey, you can actually write your own controllers, and here's the packages that let you do that. And it was only after Kubernetes was originally released that you could actually have the concept of writing your own. Like a deployment is implemented by a controller. Like there's already controllers to manage deployments and stateful sets and those kinds of objects. So we're really just implementing one for our own kind of resource, which is a GitLab. But that's still like, it's still kind of green. There's not a whole lot of solid documentation on how to implement it perfectly. And when you search for common issues, you're not going to find as many helpful links as you do when you search like Ruby or Chef issues. It's just kind of greenfield relatively.
So then I think what I'd recommend then, as we're talking through this, I can't remember the actual title. It's like Reusable Design Patterns. It's often called the Gang of Four book. But a lot of these reconcile patterns, deployment, how to do large scale operational patterning. This is something that was discussed heavily like within computer science and theoretical circles. And it's only like Kubernetes is one of the first implementations of a lot of these, because we didn't have the compute power to actually implement the stuff. Like people dreamed it up on a chalkboard in 1963, but they didn't have a computer that could do it until like 1990 something. So I feel like some of this theoretical math and how we do it and how have the least order of operations, we could gain a lot by looking at what some of those patterns are. Unfortunately, my copy is a physical copy, but it's out there, but I'd recommend that as well, because that'll help us, because stateful set it can get complicated really quick. And trying to get these reconciled, as we found, right? You've run right into the exact problem that's out there, but there's a lot of literature and writing about how to make it more efficient that I think would benefit from. Like, let's stand on people's shoulders, let's learn from other folks and bring that into our stuff with what we've learned already and try and meld too. So.
Okay, thank you. I think we are past our mark, but if you really, I would love to hear your feedback, discuss it. If you rather do it one-on-one, face-to-face, just drop me a link, or alternatively, you can just comment on the white paper itself, or just, I don't know, ping me over Slack. I am available, would love to hear your feedback. And I want to know how we can go ahead with this. I have a vested interest in this because I just like it. I think it is going to help us.
Yeah, definitely. Quick final question or two. I assume all these resources are, I almost want to call them tasks, so they're all run synchronously, so they're not.
No. The workflow runs in sequence.
It does run in sequence. Okay,
yes.
good.
No. We don't want to bring in multi-thread. Yeah.
Well, yeah, exactly.
No.
I just wanted to make sure that was the case, that they were all synchronous or in sequence.
They are sequenced and synchronous, and workflow doesn't support fork at the moment. And okay, I'm not sure if we should do.
I was gonna say, I mean, the alternative is each one becomes a coroutine that then runs and could drive you crazy trying to figure out what happened. But yeah. I could also see there might be an advantage at certain times where we build another construct here, which allows us to run some of this stuff in parallel for performance reasons, but it would have to be very selectively applied.
I suggest if you want to do that, use jobs.
Yeah, okay.
Let Kubernetes handle. Let the expert handle it. I would rather, if it's doable with this job. If it is doable with the job.
Yeah. So, anyways, just a couple thoughts. Anyways, looks good, Hussein.
Thank you so much for your time, and looking forward to your feedbacks. Have a great day.
Thanks, Hussein.
Thank you.
Bye-bye.